All right, in this video, we're given this function over here, and we're asked to find all possible tangent equations that pass through the point 0, comma, -5. Now, at first glance, you might be a bit confused about this question because you might think that every function only has one tangent line through each point on the equation. But when you get a question like this, when they ask you to find all possible tangent equations, it generally means that the point that they're giving you is not on the function. So let me just give you a simple random equation or graph over here to explain this. Let's say you had a quadratic function over here that looked like that. And then let's say I gave you a point, for example, like a 0 and -5 down here. I know that there's going to be one tangent line somewhere over here that passes through this equation, and then there's going to be another tangent line over here that does the same thing. So whenever they say find all possible tangents, it's very likely that the point that they give you is not on the function. Because if you have a point on the function, that's only going to have one possible tangent line. So when you get a question like this, what you want to do is you want to basically, and again, this drawing is not for this function here, but the steps are the same. You want to start by deriving your function. So before I derive f of x, I'm just going to rewrite it with an exponent instead because it's going to be a bit easier to derive. And now I'm going to derive this using my chain rule. So I'll start by bringing my exponent to the front, write the same thing inside the bracket. I'll subtract 1 from my exponent and I'll multiply by the derivation inside the bracket, which is just 2x. Then I'll just simplify this 2 and this 2 cancel out. And I'll move this to the denominator. So I'm only left with an x on the top. And on the bottom, I am left with square root x squared minus 25. I'll change the 1 over 2 into a square root because it's going to be a bit easier to work with that later on. Now, once you get this slope equation here, you want to think about this. Now, we don't know if there's 1 point, 2 points, 3 points. We need to figure out the number of points that have a tangent line that pass through this point over here. So what you want to do is you just want to label your point here as x, comma, f of x. We don't know if it's 1 point, 2 points, 3 points, but this represents all possible points that will pass with the tangent line that will pass through this. So I want to use my slope equation. Slope equals to y2 minus y1 divided by x2 minus x1. So this is my first point, and this is going to be my second point here. So y2 is just f of x, and y1 is just -5, and x2 is just x, and x1 is just 0, the x value over there. So I know that f of x is just the original equation over there, which is just square root of x squared minus 25. Negative and negative will make a positive, so plus 5. And then x minus 0 is just x. So this represents the slope of all my tangent lines over here. And remember, the derivative also represents the slope of your tangent lines as well. So both these equations represent the slopes of my tangent lines. So if I equate them and make them equal to each other and solve for x, that will give me all the x values for all possible tangent lines that exist in this situation. That's how you solve this type of question. So I just equate the two slopes to each other. Now I have to solve for x. So I'm going to cross multiply to solve for x. So x times x is x squared. And I'll do this one in 2 steps because you might be a bit confused. But when I cross multiply this on top here, I have root x squared minus 25, this term here. And all of this is going to be inside a bracket because there are multiple terms there. So now I want to distribute this into the bracket. So root of x squared minus 25 times the same thing is just x squared minus 25. And root of x squared minus 25 times 5 is just 5 root x squared minus 25. So now I can simplify this. X squared and x squared will just cancel off because if I subtract x squared on this side, it's just 0. So I have 0 equals to negative 25 plus 5 root x squared minus 25. I'm going to move the negative 25 to the other side, so it becomes positive 25 equals to 5 root x squared minus 25. I'm going to divide by 5, so 5 equals to x root x squared minus 25. Then to get rid of the square root, I'm going to square both sides. So 5 squared is just 25 equals to x squared minus 25. I'll move this to the other side, so this becomes 50 equals to x squared. Now I'll square root both sides. Remember, when you square root, you'll have a plus or minus. So the square root of 50, you can simplify this either mentally or with a calculator if you know how to simplify radicals. It's going to be plus or minus 5 root 2 equals to x. And this is going to be as an exact value. So we have two x values where there are tangent lines that pass through this point over here. So we need to find the equation of these two tangent lines. So let's start with x equals to positive 5 root 2. Let's find that tangent line first. I know that if I sub in 5 root 2 into my slope equation, doesn't matter which one you use, I think you'll probably get the same answer for both, but I'm just going to use this one over here. So f prime of 5 root 2 equals, I'm just subbing 5 root 2 into this equation over here. I'll do that in my calculator. I just get a root 2 as the answer. So basically the slope of that first equation is just a root 2. I'm going to go y equals to root 2x plus. And for the y-intercept in this question, the question itself gave us the y-intercept because the x value is 0. So I don't even need to calculate the y-intercept. I can automatically just do negative 5. So don't even need a plus. I'll just write it as minus 5. So this is the equation of the first tangent line that passes through that point. Generally, in more difficult questions, they'll give you a different point that's not the y-intercept. You'll have to sub that point in to figure out the y-intercept, but that's not the case over here. And let's do the second equation, y equals to negative 5 root 2. I'll just sub in negative 5 root 2 in my derived equation, and I will get my slope to be negative root 2. Y-intercept is the same, it's still negative 5. So the second equation is y equals to negative root 2x minus 5. And these are the equations of the two tangent lines that basically pass through the point 0, negative 5. Again, remember this diagram is not accurate. I just do a quadratic equation there, but you can think of it similarly in terms of this question over here. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.